My guest today is Dr. Brian Keating. He's a professor of physics at the University of California, San Diego, a fellow of the American Physical Society, a commercially rated pilot, and the director of the Simons Observatory. He received the 2007 Presidential Early Career Award for scientists and engineers for his work on BICEP, which he talks about in the latest issue of Skeptic on the cosmological origins of the universe and so forth. He is the author of Losing the Prize, a story of cosmology, ambition, and the perils of science's highest honor, and the host of Into the Impossible, a podcast about how we imagine and what we imagine shapes what we do. Each conversation brings together visionaries from the worlds of art, sciences, humanities, and technology, discussing the nature of imagination, how we collaborate to create the future. In this conversation, we discuss basically his cover story for Skeptic, which was it was on, I'll tell you the title of it, How It All Began, Cosmic Inflation, the Multiverse, and the Nature of Scientific Proof. So we discuss the laws of nature, what came before the Big Bang, what caused the bang that gave rise to our universe, why there is something rather than nothing, inflationary cosmology, gravity, how the Big Bang theory won out over the steady state theory, the difference between Popperian falsification, Kuhnian paradigm, and consensus science. We talk about string theory and inflationary theory, and there are different multiverse versions of those. We talk about the shape of the universe, dark energy and dark matter, what is time, what is infinity, what are cyclical universes, and we also delve quite a bit into intelligent design theory, because we both just read Stephen Meyer's book on the return of the God hypothesis. And so we address what we think to be is some of the shortcomings of intelligent design theory, not just from an atheistic or non-religious perspective, but really just from a purely scientific perspective and what the problems are of that. I'll be having Stephen on the podcast soon. So that will be interesting to see how he addresses some of these objections that Brian and I and many others have. So with that, I give you Dr. Brian Keating. And of course, you have the cover story. Here it is, because I'm out of the actual physical copies. Maybe you have a physical copy there of the latest issue of Skeptic. So there it is. Yeah, in the beginning, cosmic inflation, the multiverse, and the nature of scientific proof. So when I commissioned you to do this many months ago now, last year actually, this was before I even knew that Stephen Meyer was writing this book, The Return of the God Hypothesis, or that Michio Kaku was coming out with a book, The God Equation. Note the similarities of the covers. So after you finish with your Galileo book, you need to write a God book and have some cover like that. So the topics you cover in the cover story of Skeptic really have nothing to do with theism and God and religion. That wasn't the purpose of it. I just wanted to know what's the latest on the biggest questions, where the universe came from, and why does it appear to be fine-tuned, and what's the shape of the universe, and what is time, and all those great questions, which to me those are scientific questions, and you're a scientist, and but it's you don't have to dig very deep to realize, well, they do have theistic implications, because you can't help but wonder, well, where did it all start? And therefore, is there something like a sentient mind behind it all? So let's start there. I mean, you just had Stephen Meyer on your podcast, and I listened to the whole thing. It was great conversation. And so for an outsider like me, I'm a social scientist, not a physicist. So I don't really know. I kind of trust you guys, the experts, to tell me what's the latest debate, and is there consensus on this theory or that theory, or is there no consensus, and so on. So when someone like you reads Stephen Meyer's book that makes a really strong case for behind it all, behind the Big Bang, behind the fine tuning, the cosmological constants, and all that, if he had such a convincing argument, why don't you convert? That is to say, why don't you go, oh yeah, he's right. I'm now a theist. And maybe I'm even a Christian, because not in this book, but elsewhere they then go from the design universe and the designer to, Jesus really died for your sins and the whole thing, and you become a Christian. So the fact that you and other professional scientists who would read his book or his previous books or other books by Bill Dembski and others in the intelligent design movement have not converted or become theists. Why not?
How do you know that? Actually, I'm late for my church. I converted not only to be a theist, but now I am I converted from Judaism to Christianity. No, I didn't do that. And actually, I told him that because Michael, that book is huge. You're holding up Stephen Meyer's book, and when I received it in my mailbox here at UCSD in December, mid-December, or no, early December, and it said, "Dr. Keating, I love your work. I'd love it if you would consider endorsing this book. And oh, by the way, it'd be great to have it by next Thursday." I was like, okay, well, at least you gave me 7 full days to read. It's like 80 pages a day the way that Stephen writes. I said, absolutely, I can't do that. I'm happy to have a conversation about maybe doing it, but I need to have the following conversation with you, Stephen. I said, I have a problem with people like those of your fellow folks that travel in ID and in so-called Christian apologetics. And that's that I'm Jewish. I'm a practicing Jew. I call myself a devout agnostic, and I can explain what that means. But the fact is, a lot of times I'll hear the following set of logical syllogisms: that everything that began had a beginner, everything that began had a purpose, and therefore Jesus. So in other words, the universe had a beginning. The universe must have had a beginner, namely a God, and therefore that God had some purpose, and therefore the God is personal. And the God also formed in the form of the tripartite God, Jesus Christ, to not only exist in for the creation of the universe, but also for my own personal redemption. I said, I'm a Jew. I don't accept that. I accept that Jesus existed. I accept that we even know who his rabbi was in the Talmud. There's no better source of documentation of ancient Judea and Samaria than the Talmud. We know who his rabbi was. We know who that guy's rabbi was, etc. There's no doubt that he existed. The question as to his faith claims and the actual theistic implications of believing in such an entity. So I said, along the way, I'm going to tell you that I read this as a cosmologist, and I find oftentimes with William Lane Craig in particular that it's sort of it borders on confirmation bias. It borders on manipulation of evidence to support a conclusion. And that conclusion always ignores the existence of alternative cosmologies, of which there are many. And in this article for the cover issue of Skeptic magazine this quarter, I want to flesh out the fact that it is by no means settled that there was a Big Bang. Now listen, I said a Big Bang, because it seems to me that if there were multiple Big Bangs, that doesn't give more support for a creator. It might even give less support for a creator. And I wanted to bring to bear the full brunt of today's modern understanding of theoretical cosmology and potential alternative stories to the Genesis 1-1 narrative, which, by the way, Michael, you should know, that was resisted. I'm sitting in the office of a man by the name of Jeffrey Burbidge, who passed away 10 years ago, 11 years ago. Jeffrey worked with Fred Hoyle, and they were long-term proponents of the steady state model until his death. In fact, their number one protege, one of Hoyle's foremost graduate students, his name is Jayant Narlikar, and he lives today, thankfully. He's in Pune, India, and I interviewed him for my podcast, Into the Impossible. And he still believes in the steady state, and he still believes the reasons that the Big Bang are believed in, if you can believe it, somewhat owes to the fact that it comports with Genesis 1-1. So listen very carefully what I'm saying. They are saying that quasi-steady state and steady state theorists, which are the principal alternative to the Big Bang, their foremost proponents believe that my colleagues in the cosmology wing of this university believe in the Big Bang only because they're overwhelmed by the Genesis 1-1 narrative. What could be more kind of ludicrous to a practicing cosmologist? And yet, there are many alternatives to this very moment to the standard origin story that has a single Big Bang. And it's actually one of the most interesting areas of cosmology to work in. The question is, can we prove it? And I thought it'd be fun to talk about proof and the limits of proof, because that's sort of the outcome of this discussion. And you say kind of dismissively, oh, I'm just a social scientist. You're much more than a social scientist, Michael. You understand the currency of science revolves around the centuries-old scientific method, which has at its core some level of confrontation of a model or a theory with evidence. And nowadays, Michael, what's troubling me so much, I had on Michio Kaku, I know you did on your podcast. I pushed on him as a physicist. You pushed on him in really interesting ways that kind of complemented with aliens and with traversing your avatar at the speed of light. I thought you did a wonderful job in ways I could not. But on the cosmological side, we are left with an essentially infinite number of possible universes according to both the multiverse and string theory. And I said, I find this dangerous. I find it dangerous for the scientific method.
Yeah, interesting. Just to put an extra point on that, someone like a Stephen Meyer, although he hasn't said this to me, but others have. Well, Shermer, if you understood the quantum physics, or if you knew the equations, or if you understood inflationary cosmology, which you don't, you'd see that, I'm right about this particular argument. Well, you could say that about me. And you could even say, well, and you're a public atheist, so of course you're not going to accept these arguments for theism. Yeah, well, you can't say that about you, Brian Keating, because you're not a rabid militant atheist, and you are a cosmologist. And you certainly can't say this about, say, someone like the head of the Human Genome Project and National Institutes of Health. What's his name? His name just escapes me right now.
Crick.
No, not Francis Crick. Not Francis Crick. Anyway, it'll come to me. He's an evangelical Christian, and he headed the Human Genome Project, right? So he understands genetics and complexity of life, and so on. There are theists and atheist cosmologists. So, in other words, I kind of lean on this consensus theory of how science works. That we're scientists who have
Francis
been
Collins.
Francis Collins.
Francis
Yeah,
Collins.
that's right. Francis Collins. Thank you. It's hell getting old. Anyway.
Better than the alternative.
When you talk about something like, consensus science and climate science, or the Big Bang cosmology, or the theory of evolution, it's not like these guys are all meeting on the weekends to get their stories straight because those intelligent designers or those liberal Democrats are going to try to destroy American economy, so they have to have this global warming thing. They work independently of one another and in competition often for grants and journal space and so on. So they're trying to debunk each other such that an outsider like me can go, okay, the fact that they've reached consensus is a signal to me that, they're probably going along the right track here. By contrast, if things are just if the steady state and Big Bang theories were still kind of 50-50 and you guys couldn't make up your mind after 50 years, I'd begin to think, I wonder if there's a problem here. Like, again, the string theory, why I pushed Michio on this topic, and how can you test it? Because, you guys have had decades and decades, and there seems to be no consensus. Is there a conceptual problem here with how you're approaching it? Again, I don't know anything about string theory, but I can kind of see how science tends to work. So that's why I wanted to ask you that, that big question. If someone like Stephen Myers has such a convincing argument, why aren't scientists going, okay, then he's right, we have to follow this track? Maybe you don't have to become a Christian, but you could become a theist, something like that.
To give him his fair shake, I personally don't believe many of the people who profess to believe in theistic explanations truly believe in theism. Based on behavior of people that I witness, and not to say that I'm literally holier than thou in any case, but I think there's such an extreme, almost like unconscionable burden. Like I once thought, like, how could a vegan brush their teeth? Like, you're killing all these microbes, and it's like, I think ridiculum ad absurdum certainly would apply, but I think in Stephen's case, I think he is obviously very convinced. But he also has the intellectual honesty, at least, to admit that he can't prove it. And I push back in several different directions. So one is the lack of unanimity, I would say, and lack of a dearth. In other words, there are many plausible alternatives to the standard Big Bang model. Second of all, even the models that he espouses in the book, have serious lacunae in them that make them either untestable, unprovable, unverifiable, and subject to the multiverse kind of out paradigm. But they're tentative in a way that they cannot even be expected to have falsifiable evidence against them. Now, I thought it'd be interesting for us to talk about Karl Popper for a second. You're not a physicist, but Karl Popper has enormous influence on science, even though And Stephen actually, brought this out because I did push back at one point, and we did talk about Popperism, and I knew this, but by the demarcation, assay, by the statement that you can judge if a theory is scientific via the ability for it to be falsified, that is the sine qua non, is no longer held by even philosophers of science, let alone should be held by scientists. I claim that's because that it is held sacrosanct, Michael. I claim that's because physicists, remember, did you ever hear you must have heard of penis envy, and I know we can say such words, but there's also something called physics envy, where some of the sciences had envy of how rigorous physics can be. But actually, I think physicists have mathematics envy, because we cannot prove the boundaries of what we do or do not know in the Gödelian sense, in the sense that we don't have an incompleteness theorem for physics because we don't prove things. I never go out and prove things. That's not what I do. We just disprove things. So physicists, in lieu of that, have resorted to Popper, and they kind of have this, even though Popper himself said it's sometimes very useful for a theory to remain untestable, maybe for some time, because it allows a hardening, kind of an annealing of the true theory to come out. My question is, we live in reality. Although many of our listeners may not believe that, we have to get jobs, we have to get grants, we have to teach students, and in so doing, we need resources. And those resources can only be allocated in a finite sense. There's a science, I always say, Michael, lately I've been saying this, and again, you've been so influential on me as a podcaster, as a thinker, and I'm delighted to be a part of Skeptic now. It's funny, having an article in Skeptic and also a video for Prager University. I think that might be unique, although I'm not quite sure, in the same month. But nevertheless, thinking about what is the ultimate limit of what we do, I say nowadays science is not a finite game. It's not a winner takes all game where I'm right, therefore Michael's wrong, and then we just go on. But funding sure is. There's only so much funding. There's a finite amount of funding. There's a zero-sum funding, and just like there is for podcasts, I mean, we can only listen to one podcast at a time. So how do you divide your attention, the most valuable commodity of all, and how do you divide these resources? And so in reality, string theory and inflation, these twin pillars of modern day cosmological physics, now are sort of dominant for almost 40 years. And to the exclusion of almost any other paradigm receiving funding, attention, and perhaps the resources that it needs to provide. So should it be surprising that we find ourselves in a situation where these are touted as proven? And I find that, again, kind of dangerous for the progress in physics that I hope to engender.
Yeah, I think of, just to close the door of how I opened was, I think of these kinds of arguments that intelligent design creationists make as vastly superior to the old arguments made by the young Earth creationists, say in the 60s and 70s, and in the Gish Gallop, when Dwayne Gish would plow through 300 slides and then give you 5 minutes to respond. Those kinds of arguments, these guys have greatly improved on that. And yet I think they're good arguments if you already believe. That is, if you're already a theist, particularly if you're a Christian and you believe that, that a sentient being of omniscient and omnipotent power, created the universe and us and cares about us and so on. All these arguments are pretty good. I mean, it's like, they're very reinforcing in a Bayesian kind of way. I already believe, so I'm piling up more and more confirmatory evidence for my beliefs. And then to the Bayesian thing, I think Popperian falsification is just one element of science. Scientists do reason in a Bayesian way, where you guys are trying to update your priors. So you run an experiment, and the experiment comes out one way or the other. If it comes out in a positive way, that kind of ups your prior to the credence of your theory being true with a small t, no capital T's. And I think what's particularly confusing to a lot of us, again, outsiders, is that the areas you work in are so sort of abstract or non-concrete. So I'm going to read something to you here from Steven Pinker that he wrote me in a little group email after I had Michio Kaku on the podcast. A couple of my cycling friends who listen to the podcast emailed me commenting on what I just said. This stuff is also abstract, Higgs boson and the inflationary this and the flatness of the universe, or what, and so and so Steve made this observation, which he's just so good at this sort of thing. He says, it seems to me that any ultimate theory in fundamental physics is going to be hard to test, because at some point we're bound to ask questions that just happen to be inconvenient or impossible for mortal humans to study for practical reasons. For example, you can't build a particle accelerator the size of the solar system. But the universe wasn't created for the benefit of scientists, and it may be our bad luck that we don't have the means to build labs to test every theory. That's when elegance, parsimony, consistency, scope, etc. are the only criteria we can apply. And then he makes a comment, because we also discussed the nature of consciousness. It also seems inevitable that at any level of depth, the theory is going to look pretty abstract, almost vindicating a kind of idealism where the only reality is the math. Here, sorry, I'm still continuing with the abstract physics. One wouldn't expect a theory to add a note at the end of its equation. Oh, and there are itty-bitty little tiny bits of hard stuff out there corresponding to the seventh term of equation 39. And then he says, as a cognitive scientist, I'm always mystified by claims that consciousness can only be explained by some highly abstract or counterintuitive or abstruse theory in physics. That would be called for if ESP existed, but as Michael has documented for decades, it doesn't. 100% of consciousness depends on photons striking rods and cones, vibrating sound pushing against eardrums, neurons transmitting chemicals across synapses and computational networks, etc. If consciousness is sourced directly from fields, here he's referring to like quantum fields, based on one theory, why do we have to turn on the lights and open our eyes to see? Such a great comment. So here I'm wondering, are we at a point, you guys, you physicists, theoretical physicists, and cosmologists, where you're just kind of bumping up against the wall of all we have now is math, because we can't really test these super abstract theories?
Well, there I've got good news and good news, because actually we can test the alternatives to, say, inflation, which produces this, resplendent, extravagant multiverse in the cosmological. So I should say, let me take a step back. There's two different types of multiverses at minimum that physicists talk about. And one of which is one in a cosmological sense, that just as we have multiple planets, we have multiple stars and galaxies, et cetera, there are multiple universes. So that's just the evolution of the cosmological principle, the Copernican principle. So that's something that almost seems natural, that there should be other universes. And of course, there's nothing even in the bounds of ordinary cosmology that precludes there being a universe right next door, as some one quipped once. There's a heck of a universe right next door. Let's go. But there could be a universe that's literally, one light day away from our observable universe's boundary, the light cone from which we can receive information during the next day. And we'll find out about it splashed across the front page of the New York Times tomorrow, the Santa Barbara News Press, or the Union Tribune. There's another type of multiverse, which is that there are universes separated in space and or in time, and they're separated in many different ways by not only their differing physical phenomena that take place. In other words, there could be so many that, I host a podcast called the Brian Keating Show, and you host one called the Into the Impossible podcast. On the other hand, there could be universes where there's 6 dimensions of space and 1 of time. There could be universes where the speed of light is slower than our speed of sound, et cetera, et cetera. So there are limits, by the way, to the existence of life forms like ours in the so-called weak anthropic principle sense. But let me ask this question. I've been thinking about this one a lot, because I don't think this has really been addressed. I asked Michio Kaku about this. And I said, you guys always who talk about the string multiverse, which is the latter form of the multiverse that I just spoke about, you always talk about that as having, the different mass of the proton, the speed of light, the nuclear force will change a little bit. But what's to prevent the laws of logic that modus tollens applies or not in another universe? It seems to me that if you can let everything change, and that 2 + 2 could be 5 in another universe, then it's basically hopeless, because in that case, you could never potentially test the non-existence or prove the non-existence of such a universe, because we would not only lack the experimental tools, what Steven Pinker's talking about is enhancements to our own sensors. So I did a podcast with Deepak Chopra and Leonard Mlodinow, and I talked about we talked about, like, I called it sensors and sensibility. It's like what we see is what we interact with, and then Michael's claiming that we don't have any free will because everything's foreordained in the wave function of the universe, whatever that means. And then Deepak saying, no, there's all this quantum decoherence, and it's like, yeah, grudgingly I have to say, both of them are right and both of them are wrong. The problem is we don't observe the universe outside the universe. We are observing it from within. And so we are subject to certain basic tenets, and the lack of our ability to gauge the existence of another universe may be due to physical limitations, namely the finite speed of light, the finite age of the observable universe, etc. So I think of these as cosmic chicken or egg problems. In other words, which came first, the universe or the laws of physics? Because if you ask Lawrence Krauss, who's going to be a guest coming up on my podcast for his climate change book, if you ask him, he'll say, oh, the laws of physics, and the Vlinken theorem, which he popularized in his book called A Universe from Nothing, suggests that the universe can emerge, from this balance between negative energy and positive energy, canceling out. So zero means nothing, means it can come from nothing. No, that's not actually correct. That's not an interpretation that even Vlinken recognized. It's merely the statement that there had to be a pre-existing universe in the sense of the laws of quantum mechanics, the laws of mathematics, etc. What Stephen Meyer gets into is that only such things that have boundary conditions, what we call in physics, if you look at a pendulum swinging back and forth, Michael, you can't tell me where I started the bob of the pendulum. You can't tell me because you don't know the initial conditions. You just know the total energy in the system, but you don't know the initial conditions. Similarly, you have to know the boundary conditions of a system. You have to know, well, what volume is it contained within? And what are the interactions of the measurement apparatus on the subject being measured? So for all these reasons, I find it very difficult to glean from the current book that we're discussing with Stephen Meyer's book, that because the universe started in low entropy, as many people, if not all people, believe, that is evidence of order, because that presupposes a pre-existing pre-order. And so I asked him, I said, Stephen, why is it that if you were alive, Michael, in the very early universe, apart from the first 3 minutes, the next billion or so years would have been the most boring, in recorded history. Almost nothing happened. Hydrogen formed over here. That's about it for hundreds of millions of years. And then if you just think about us as our DNA didn't emerge for a very long time, at least on Earth. We don't understand exactly when the first humans that look like us. So in other words, everything was created by this mind with a purpose, according to you, Stephen. And yet, why was there, billions of years waiting between events? In other words, the clock, you could have looked back and forth. And if you looked every billion years or so, you'd say, this is a pretty slow universe. He didn't have an answer for that. He said, God can create the Hubble deep field. He can create anything he wants. So I found that very unsatisfying.
Yeah,
probably as unsatisfying as he finds.
I'm surprised he didn't come up with something like this, which I've heard. That is to say, to an eternal deity, what difference does it make if it's 14 billion or 14 trillion? Eternity goes way past that. So, whether it's 10 years, 10 million years, 10 billion years, 10 trillion years, they're just zeros after the one. And to an eternal being, it doesn't
Michael,
really
you
matter.
have a puppy, right?
I have a puppy. Right? I have a dog. Yeah.
You have a dog. So you got that dog when you're in your 50s or whatever. Right? You could ask the same question. I waited. It's not the duration that you demurred from making a decision or making a phenomena instantiate itself. It's the relevant timescale is the timescale, and when that thing started to take action and have effect, that you, as the designer, if you will, of that dog's particular life, had a purpose for it. In other words, intelligence. There are things that can appear intelligent, but they actually convey no real information to us, right? It's patterns, like a license plate, like Feynman's famous license plate thing. On the way over to this lecture, I saw the following license plate: 6Q7 4TV. Oh, that's intelligent. No, it's not. It is absolutely meaningless. It was created by an intelligence, but so too with your dog. I would say, what is if the purpose of your life up till getting that dog was getting the dog, which it would seem to be, if we are the pinnacle of creation, which I can actually take some stock in for practical reasons, not me personally, but nevertheless, why wait so long? Why create so many different universes?
Your point is that if it's all here for us, why wait 13.8 billion years or 13.7, I guess, to create life forms and so on. Well, I have the same problem too, as well as this problem, which I want to ask him about. And he started to go down that path, but then he kind of changed the subject. That is, how does the deity, the intelligent designer, how does God do all this stuff?
Yes.
And I would push it. I would push it even more than this. It's the same problem that Descartes started with a dualistic worldview. How does mind interact with the stuff? Like to ghost hunters, I always ask them, how does the ghost know to turn right at the hallway and open the door? And how does the ghost knock the picture off the wall? The ghost is supposedly this non-material substance. It's the same problem we have with consciousness. How does a thought cause my muscles to move? Well, the synapses, and the neurons fire and so on. Yeah, but how does the thought cause the neuron to fire? Well, other neurons are firing.
Right.
Yeah, those are just physical systems. If you impute behind that a mind, how does the mind interact with the physical stuff? And so I would just ask, like if God is performing miracles, how does he do it? Does he, reach into the cells and let's say cure Aunt Mary's cancer? Does he go into every cell in the tumor and reprogram it so that it dissolves and the tumor gets smaller? It's exactly how does this happen? And, the only answer you're going to get is, well, God works in mysterious ways, or nobody knows, or that's an unanswerable question, or I don't know what. At some point.
Similarly, to push back. Yeah. Oh, go ahead.
No, good. That's it.
Yeah. Exactly my feeling. You're echoing beautifully, Michael. But I also can push back because I've heard talks by, say, Sean Carroll, and Sean will say things like, well, God is not a good theory. He, of course, is too smart to say there is no God. I can prove it. He'll say the probability of God is less than a few tenths of a percent, but the probability of the multiverse he puts at 50-50, and it depends on what multiverse. I think he believes the multiverse in the Everettian many worlds conception is 100%. He believes that is the correct interpretation of quantum mechanics. But nevertheless, just thinking cosmological multiverse, and I'll say to him, well, what is the evidence for that? Well, he says, well, God could and should produce the simplest, most parsimonious universe first, and that would be an empty universe. In other words, the fact that our universe has stuff in it, stuff that can think of things, is now evidence that God is at least not parsimonious. And I say to him, well, and he says, yeah, just look at the Hubble Deep Field. And I said to him, well, Sean, he goes, like, look at all those galaxies. Even if there is life there, we can never interact with it, and therefore it's pointless to our existence on Earth. So we cannot be, most people think that Galileo showed we were not the center of the solar system. He didn't do that. He just showed that there are other rightful places that could claim to be the center of the universe, and that was enough to at least disprove the thought that we were the center of the universe, right? So he said, well, those galaxies over there have no purpose to us, and if we are the pinnacle of creation, it can't be so that those other things exist for any purpose that matters to us, because they don't do anything for us. And I said, well, Sean, the same thing could have been said about uranium in the year 1842. They didn't know about uranium, and they didn't know about quantum mechanics and all these. And by the way, 2 weeks ago, I had on my podcast someone discussing a new potential fifth force of nature discovered at the Large Hadron Collider. That's a force we didn't know about until 2021, if it holds up, which it may or may not. But the point is that we don't yet know the purpose for many things that scientists discover. And again, I'm pushing back as the theist now. And I said to Sean, I have my upstairs professor colleague. She studies that galaxy over there in the Hubble Deep Field. And his response was, "Oh, come on, you can't be serious." Like, I was like, that's a purpose. Like, I've just provided you one particular person in the universe for whom that serves a purpose, and you're saying that doesn't qualify as well. So too does the evidence for the pre-existing Hilbert space that contains an empty universe in quantum mechanics that Sean believes in. That is enough to refute the existence of a designer who had a purpose for us specifically. So I find, I like to give people grief on both sides, Michael. I don't know. Is there a name for my condition? I like to push back on both the theist and the atheist. I think that makes me an agnostic. I'm not sure.
Yeah. What is what do you call it? Militant agnostic? I don't know, and you don't either. Something like that. Is that what you are? How do you define agnosticism?
Yeah. So I define agnosticism, again, similar. You once told me you don't call yourself an atheist usually because that means you're defining you by what you're not. So I shouldn't define myself by what I'm not. But I will say that I know what Michio Kaku is not. I know what the late great friend of mine, Freeman Dyson, was not. In other words, they would not go to the same church that Richard Dawkins does not go to. And so there was no functional way for an intelligent alien, if such exists, to look at Michio Kaku and distinguish him functionally from our friend Richard Dawkins, right? So there's no way to tell in practice which one is which. And so we know that we are the sum of a lot of what impacts us, our behavior. I think you're a behaviorist to some level. I certainly am. And I believe that, behavior is a manifestation of what our worldview is. And so Michio doesn't go to church, and he may say that he's agnostic, but I kind of feel, I wonder, I hope it's not true, that he is like Stephen Hawking. Stephen Hawking put things like the mind of God at the end of his brief history of time, and so does Michio Kaku. And I think sometimes that's to not turn off theists. And I hope that's not the case for Michio. At least I know it was for Hawking, but I'm actually you'll like this guy. I'll send him over your way if you're interested. Charles Seif at NYU, who wrote Zero, The Birth of a Dangerous Idea. He just wrote a book called Hawking, and it's about the business of Stephen Hawking and how he was a showman. And it's a critical.
That's clever.
It's the first critical biography of Stephen Hawking, as opposed to all the hagiography that exists around him. And one of the pieces of hagiography was that he was a kind man and he didn't care if people believed in God. He was pretty militant in all of his books that God did not exist, and he could prove it. And his way to prove it, Michael, was one, inflation, to invalidate the need for God to establish the universe, and two, string theory, or what's called M theory, which is what Michio describes, and that was to instantiate the laws of physics. And neither one of which is held as proven or ever could be, thanks to even the discussions, according even to their proponents, such as Alan Guth and Michio Kaku.
Here is what Leonard Mlodinow writes in his memoir of Stephen Hawking. So here he is, Leonard is quoting Stephen, who typed this out to him. A law is not a law if you allow God to intervene, he said. That leaves two possible roles for God. One is to choose the initial condition of the universe. We got rid of that with the no boundary proposal. I wrote about that in A Brief History of Time. The other possible role is for God to be responsible for choosing the laws and making a universe based on those laws. It shall arise in the last chapter of our book that it is not necessary to invoke God for this either. He's referring to the grand design that they wrote together. Hawking continues, I want to make my position clear without being violently anti-religion like Richard Dawkins, he continued. I have just been sent his book, The God Delusion. If you want to see it, get Judith. I agree with most of it, but I don't think it is necessary to be so aggressive. And then at the end of the memoir, in the closing pages here, Leonard recalls the day that that book came out, The Grand Design, and Stephen's secretary or assistant, whoever, calls Leonard and says, have you seen the Times, she asked. The New York Times, I said. Yes, I'd read it. Not the New York Times, the London Times. Haven't you seen it? And Leonard says, Judith, who here reads the London Times? Well, Google it and look at the headline. It says, quote, Hawking, God did not create the universe. It's creating a furor. Then Leonard continues, that's wrong, I said. We said God isn't necessary for creating the universe, not that physics proves he didn't. Well, the press is all over it and Stephen can't handle it all. We need your help. You need to do some interviews. So, he's basically saying, don't put Hawking in the same category with Richard Dawkins in terms of how militant.
Well, but
yes.
But I mean, he was, in this book by Charles Seif, Professor Seif, really makes the case that he cultivated that image, but he was much more kind of calculating behind the scenes. Those two things that he talks about, A Brief History of Time and A Grand Design, those are accepted 100% by the public and almost 0% by practicing physicists.
Really?
So it's a total sales job that absolutely. Well, inflation is not essentially, it's not provable in the sense that you could only, you can't falsify it. As we said earlier, you could not show evidence that's inconsistent with inflation if inflation could have existed. So for example, let's say that there's evidence A. Evidence A will occur for inflation enough to provide supporting evidence for it. And if evidence A occurs, that means you can reasonably infer in a Bayesian sense that inflation took place. Well, there's a couple things that could happen. One, inflation didn't happen, in which case you won't see evidence A. But also, it could be that that inflation did take place, but it did so in a way as to provide noisy enough data that you can never detect it with confidence level greater than 1. So in that case, you'd be in this no man's land, and it becomes a matter of taste. That applies to the inflationary component he brought out. And actually, he didn't play a huge role in inflation. And this book makes out a big point that Hawking would write papers with people. And in this case, he wrote a paper with my colleague at UC Santa Barbara named James Hartle, the no boundary proposal. And in that, I believe that they probably did, or Hawking, he would write papers and people would say, yeah, I'll be on the paper with you because it's going to get 1,000 times more citations than if I write it by myself, knowing that Hawking would take all the credit for it. Actually, Andy Strominger is quoted in this book, who's a renowned professor at Harvard, saying that in his last paper in 2017 or so, he made that calculation and he decided to go with it, even though he knew he'd be written out of the history books for credit. But in the context of the no boundary proposal, if you read the book, as I did recently, and again, I tried to read it when I was 18 when it came out. I couldn't understand it. Now I'm a practicing cosmologist. Like, not only is it like I don't want to say trivial, but it's simple for me. And I'm not a theoretical cosmologist, by the way. I'm an experimental cosmologist. But it was simple enough for me to know that he made a very, very almost disingenuous trick in that book. And that was in the calculation where he talks about time not having a beginning and there being nothing north of the North Pole and that being a stupid question. He makes what Stephen Meyer points out is an exact accuracy. He makes a mathematical approximation. He converts the time domain into what's called imaginary time, which it doesn't have a physical existence, cannot be measured. It's merely a mathematical trick. If you remember anything about imaginary numbers, the imaginary numbers are the square root of negative numbers, which shouldn't exist according to normal experience with numbers. We don't have a number that's the square root of -2. Such a thing doesn't exist. But when you introduce a negative square root of -1, such things can exist. Hawking does that, and he says, I'm going to do a little mathematical trick, but it's just a trick. And then later on, he goes, because of that trick, now we know that time is imaginary, and time could start with no beginning whatsoever, just like there's no beginning of the Earth's surface. It's so disingenuous and the worst possible read of it. At best, it's like a convenience. It's like saying, I'm going to do like some mathematical, gibberish here. And then at the end, I'm going to say, I'll make a conclusion, but I'll go back and I'll remind you, I still have to address that. He never addressed that. And so that is not accepted by almost any working cosmologist today. The first book, The Brief History of Time. And I ask you, did you come away from your conversation with Kaku being convinced that string theory or M theory is correct? And that's why we have the laws. It's basically the anthropic principle. It's saying there's an infinite number of universes. Infinite. Because the vacuum of string theory, the lowest possible energy state that a theory can have, is completely undefined within the theory. And here's where I don't like what Kaku does. Kaku says, well, it's not fair to ask that we test string theory today because we don't know its principles in final form. I know that you're not a physicist, but you know for sure that we don't have a final theory of quantum mechanics either, right? We have interpretations, we have principles, but you and I wouldn't be talking if we didn't have the laws of physics that govern quantum behavior to produce the transistors in the screen that you and I are conversing through. So it's very different. You can't say that the lack of a underlying principle is a deterrent, an impediment to getting something useful, like a transistor that produces an image on a screen. Because we have examples where such things occur where we don't understand the principles that govern them at their most basic behavior. So I think that is not an honest assessment of why we should abandon the 400-year-old scientific method. I came away highly unconvinced.
Interesting. Yeah. I guess I am too in that version of the multiverse, the string theory version, if I'm getting that right, where there's somewhere there's a version of you and I almost exactly the same, in which I have more hair than you instead of vice versa. And that just seems pretty.
You have to pay your hair bills, Michael. That's what I do.
It seems pretty ridiculous. Okay. It seems more likely if there's a multiverse that it's these other bubble universes unconnected to ours. But then the theists could reasonably retort like we do to them. You need to be more specific in step 2 here, referring to the Sidney Harris cartoon with the two scientists at the chalkboard with the massive equations, and then a miracle happens in the middle. That we're accusing them of saying you're just making this leap of faith. There's no evidence for this. You're just believing it. You're just asserting it. And they could then come back to something like this untestable string theory. You're just making this up, this multiverse thing. Now, but to make a slight point here to ask you this question, because Myers makes this point, as do other intelligent designers, you guys just made up this multiverse to avoid the inevitable conclusion that a deity is behind it all. And as I understand it, that's not where the multiverse comes from. It comes out of the equations, or it's a derivative of some mathematics or something like that. In other words, you weren't sitting around going, oh, crap, we're going to have to say that there's a God, and I don't want that, so I'm going to make up this stuff about the multiverse.
Well, right. So exactly. It's funny because these are relatives of the so-called Copernican principle. So I think it was the 500th anniversary of Copernicus's birth. There was a kind of a festschrift, a party held for Copernicus in Krakow, and so there were scientists. I think it's Brandon Carter who came up with this proposal that he called the anthropic principle. That is sort of, so the anthropic principle stands kind of opposite from the Copernican principle. So it's kind of ironic birthday gift to get for old Nicholas. But nevertheless, the multiverse emerges from different phenomena than the string theory. That's actually true. So I would say string theory contains within it a more natural multiverse, which is called the landscape in the language of string theory, than does cosmology in the inflationary multiverse. Because if inflation took place, you can have inflation without a multiverse, but you can't have string theory without some form of a landscape. In other words, there's a more prolific, more extravagance in the landscape of string theory than the landscape of inflation. And part of the proof of that is that you can have string inflation. So, what's better than chocolate or peanut butter, right? You put them both together. And in the case of, the string theory, it's sort of even bigger in the sense that inflation can occur continuously for all eternity, whatever that means, in the multiverse. And that produces an infinite number by virtue of the fact that given, a finite probability to create a universe per unit time times an infinite time, you'll produce infinite numbers of universes. But in the string theory, it's actually impossible to put in what this initial condition or boundary conditions are for the vast possibility of quantum mechanical states that string theory could produce. The problem for me as a practicing cosmologist who doesn't is open to either scenario is that, well, what if it is true that we live in a multiverse? So in that case, is there any predictive power? Like, can you even use, as I said earlier, the laws of logic? I mean, if there's a 100% probability that we exist in some other universe, and we're doing opposite things, et cetera, like hair or podcast names or whatever, then there is no prior. In other words, it's basically everything can happen that's not mathematically well defined. In other words, something that's mathematically well defined should be subject to a computer could solve it. But computers can't solve things that are unbounded. You get this not a number like NaN, which I used to think was like nana, but it's not. It means not a number. And so computers can't handle it. And so either the universe is not computable in that we can't encapsulate the full complexity of the universe on a computer, or the problem is ill-defined in that you have a measure, a mathematical term of a density of probability that is ill-defined. In other words, it doesn't operate on the normal laws of probability. And for that reason, I think it is true that it could be construed as almost hopeless. Like if I tell you, Michael, you're the chief of the NSF, and I said this to Kaku the other day, I said, you've got string theory on one hand, and you've got effective quantum field theory on another. You got string theory and some alternative to it called effective field theory, or Eric Weinstein has a geometric unity, et cetera, et cetera. You can only fund one. What do? You're the director of the National Science Foundation. Oh, I think you should give it to both. But in this case, maybe if you agree with him, that would be a huge raise for alternatives to string theory and a huge, tax on string theory, because it's basically almost in every physics department in the country, there's someone who understands and works on string theory, and there's people that believe in string cosmology. And so this is where it gets very dangerous. And I think people like Lee Smolin and others have written on this extensively, that physics has stagnated. in a lot of ways, fundamental physics, not other fields of it, particle physics, has stagnated. We haven't come up with a unified theory of, so-called gravity, unified with other theories. Although, by the way, Michael, people are really obsessed with the theory of everything, right? The TOE. But there's actually another theory that we also don't know, and that's called the grand unified theory. And my point, and that's where the laws of the nuclear force, the electromagnetic force, and the weak nuclear force combine together into one force, the same way that electricity and magnetism unify into one force. And then the theory of everything are those three forces married to the gravitational force, and that creates the theory of everything. So we're kind of looking past the goal lines right now. We're kind of like celebrating in the end zone. We haven't discovered a theory of grand unification yet. And yet we're kind of obsessed with string theory as the theory of everything. So, I just wonder if we're not putting, Descartes before the horse.
Yeah. So the question is it just a really hard problem? And along the lines of what Steve Pinker commented, we just don't have a solar system size particle accelerator to figure out which is the right theory in a test. Therefore, we're just kind of making speculations. Or have you guys all gone down the wrong path? String theorists, whatever. Gone down the wrong path.
Yeah.
And there was that book like 10 years ago called Not Even Wrong. I forget the author's name. Basically it was saying string
Peter
theory.
White.
Peter
White.
Yeah. So that string theory is just completely off the rails, and you got to try something completely different.
So we actually have a particle accelerator the size of the universe. It's funny when people say things like, "Oh, we just need a bigger particle accelerator." 10 years ago, Michael, if I told you, would you like a particle accelerator that takes 10 to the 80th or 10 to the 20th nuclei and smashes them together, two of them together at the speed of light, maybe 90% the speed of light? You'd say, hell yeah, that would be awesome. And it's called, a coalescing neutron star, binary neutron star merger. And we detect them every day with LIGO, right? So it's like people think too small. We actually have the most advanced thing. We have a particle accelerator that's galactic sized. It's called a cosmic ray detector. We also have a potential detector of primordial waves of gravity, which I talk about in this month's article, in this quarter's article, which is that we are looking for what is called the polarization of the cosmic microwave background radiation. And if we find a particular type of pattern of polarization, that would be indicative that not that the inflationary theory is right, but the alternatives are wrong. So it's actually a lot more hopeful than Pinker would lead us to believe, in that we can actually make crisp falsification type tests, but not of the dominant paradigm. So that's the interesting thing. There's no way to test the dominant paradigm as far as we could tell. And even by their own admission, even by the Alan Guths and the Andre Lindes, we cannot test the theory, because any time, and as there's one of the founders of string theory, or one of the greatest contributors of string theory, who worked with Ed Witten on the so-called Seiberg-Witten equations. His name is Nathan Seiberg. He's at the Institute for Advanced Study. And he says, most string theorists are very arrogant, he said with a smile. If there is something beyond string theory, we will call it string theory. So it's, but the alternatives are not, that's not the case. We falsified the steady state. We can falsify the bouncing, kind of revisitations, reincarnations of steady state. And, but we can't prove or even falsify the inflationary or string theory landscape proposals. So, I ask you, well, putting on your good Bayesian hat, if I tell you that all these other things are falsified, what prior do you ascribe to the dominant paradigm? That's one question. The other one is, if they're getting all the money, like, would you expect an alternative cosmology like Paul Steinhardt and Neil Turok discuss? Or would you expect, or Roger Penrose, even winner of this year's Nobel Prize in Physics, would you expect that they would have as much attention as the dominant paradigm, even though the other paradigm is not testable in a falsification sense? In other words, if you were just an intelligent funding director, you might say, well, I'm going to put some money in the thing I can at least prove wrong. Not all of my eggs in one, or all of my dollars in one basket to be proven possibly right or confirmed.
Interesting. So you're saying perhaps string theory as the dominant theory has gone down the wrong path, and that we should shift some funding over to these other areas.
It's not clear that every incremental dollar that you put into string theory would have as much impact as exploring alternatives or, thinking of tests that could potentially prove it. It's not clear that it's hurting for funding, put it that way. And it's certainly not hurting for publicity, right? I mean, it's certainly not hurting for popularity and publicity.
Well, this is Michio's book. It hangs on string theory. Well, we'll see. I'm going to ask you back to that Hawking book, because I've not seen it. Hawking, very clever title. I've always wondered, is he really a world-class, one of the top ever physicists, theoretical physicists, whatever? Or does his condition and his heroic, continuation of his work in life, despite these incredible conditions against him, kind of elevate him into almost a godlike status? I used to see him every couple of years. He'd come to Caltech and give a public talk. And, it was quite a show when he would show up at Caltech. It'd be like, well, Stephen is speaking next Wednesday night at 7. All right. Well, like at 2 p.m, there's people lined up, out in the lawn playing Frisbee and waiting, for their free spot in the 1,100 seat auditorium. It's like, wow. And then, he rolls down the aisle with his helpers in his chair, standing ovation just for showing up, before he even speaks. And, people are just hanging on every sentence. And of course I get it because, his condition, his heroism and so on. But I always wondered, is he, way up there in the pantheon of the greatest of all time, Newton, Einstein, Feynman, Hawking, or not? I just really have no way to judge that.
No, and that's a big thesis of this book. It sounds like you'd really enjoy it. But the book actually goes through as a physics. It goes in reverse from starting with the movie about his life and maybe his final papers, all the way back to his 1965 thesis with Dennis Sciama at Cambridge, at Oxford. I think he was at Oxford, and then he was teaching at Cambridge. But no, it makes the case. And actually, Michael, as you're right, he would come to America. He didn't get there on British Airways. I mean, he got there on a private jet, and also oftentimes the private jet was so even not inadequate. He had to take an ambulance jet from Cambridge to Caltech. That's not inexpensive. So he had all these backers. There's a guy who backed him who had established a Stephen Hawking chair at Texas A&M, and he would have him come out. And then once he was working on his final papers with like Andy Strominger and others, and every time he'd get approval from his doctor to come out on the ambulance private jet, which is much more expensive than a regular private jet, because there's only like one or two in the world that could actually do it. And so Andy Strominger talks about how they had to get him out, and the doctor said no. He had gotten really sick. He had just had a flu, I think. And this is like 2017, about a year before he died. And the doctor said no, he's too ill to travel. And then in the book, it says that his colleagues wrote to his doctor and said, if you don't let him come, it may cost a Nobel Prize. And I thought it was perfect for my book. Losing a Nobel Prize is all about how scientists worship the Nobel Prize as a kind of gilded graven image that literally has Alfred Nobel's picture on it. And we have as much of a religious proclivity as any secular, humanist does, except we think it's all great because it's just wrapped up on this fun thing called the Nobel Prize. But it was funny to me that his doctor only let him go at great risk to his own personal health and maybe even the guy's medical license because of the potential to win a Nobel Prize, when actually there was no chance of him winning a Nobel Prize. He did a lot of good work. What kind of hampered him, as this guy talked about. So for a while, I was kind of frustrated by Hawking because I heard him speak several times. I heard him speak only once in my life, and that was in the 90s in London at a Royal Academy meeting. And he gave a public lecture. And at the end, someone said, "Why did you write A Brief History of Time? It's rumored that no one's ever gotten all the way through it, not even you, and nobody understands it." And in his computerized voice, I remember this distinctly, Michael, he said, "Because I had to pay for my daughter's college." And everybody laughed. It's kind of a cute line. But only now do I realize how much he had to go through. And Leonard Mlodinow's book that you had, The Biography of Friendship, I had Leonard on my show. And I realized he had a form kind of Stephen Hawking Incorporated, as I call it, or Hawking, as Seif calls it, because he had to be turned over. Imagine being turned over every hour when you're sleeping to drain your tracheostomy and have fluid, and like you couldn't do anything. You never had privacy. Your spouse was like your mother or your parent, like wiping you. It's disgusting. I can't imagine how much respect I have for him on one hand, but it's impossible not to think that didn't play into this. He like literally I interviewed Neil deGrasse Tyson the other day, and he said even during COVID, I couldn't go down the street with a mask on and not get recognized. And that's like one of Neil deGrasse Tyson's, biggest kind of frustrations, just like he has no privacy anymore. Well, Stephen Hawking said, I can't like put cloaking devices on my wheelchair. Like everyone's going to know who he was. Everyone always wanted his time. And so I don't begrudge him for doing a lot of things for financial reasons, because he had to take care of it. Just like Galileo, he had ex-wives and children, from different people to support. And there was this constant need and terror. Who else was going to provide for him? But is going to make do on a professor's salary?
One of the theses of this book is that he's not in the pantheon of the great physicists.
No, definitely not. No, he's as I said, the two biggest things that he claims are his reasons to not believe in God: the Hawking-Hartle theorem and the M theory that he didn't contribute to but popularized. Those are not accepted by the lion's share of practicing physicists. The work he did on singularities is very important, but then again, he kind of disavowed that to work on the no boundary theorem, which kind of obviates the need for a singularity. And then the black hole Hawking radiation is incredibly interesting, fascinating mathematical work that suggests that, black holes may emit light with an equivalent temperature of 1/trillionth the temperature of the sun that will never be observed. So for those reasons, you might make an argument that Penrose, did this great work on black holes with Stephen, and so since Penrose won the Nobel Prize, maybe Hawking would have, but Penrose made a numerous amount of contributions far beyond just the black holes for which he was recognized. Hawking was much more narrowly focused, and I think it's impossible to imagine how much he did, with so little physical ability starting in the early 1980s. But certainly it was his esteem amongst the general public is far eclipsing of his contributions to most practicing. Like the amount of citations that he has, the papers that he's done are very limited in the practicing work of physicists today.
Let me ask this next question by prefacing it with a quote from Darwin. When The Origin of Species came out, of course, there was some hullabaloo about its implications for theism and the need for a designer to explain life and so on. And so in the second edition, he addressed this question, is the theory of evolution by means of natural selection a threat to belief in God? And recall that Darwin's wife, Emma, was deeply religious, and he consciously avoided being too militant about his eventual agnosticism. He never called himself an atheist. But here's what he wrote about his own theory. I see no good reason why the views given in this volume should shock the religious feeling of anyone. It is satisfactory, as showing how transient such impressions are, to remember that the greatest discovery ever made by man, namely the law of attraction of gravity, was also attacked by Leibniz as, quote, subversive of natural and inferentially of revealed religion, close quote, from Leibniz. Darwin continues, a celebrated author and divine has written to me that he has gradually learned to see that it is just as noble a conception of the deity to believe that he created a few original forms capable of self-development into other needful forms as to believe he required a fresh act of creation to supply the voids caused by the actions of his laws. So my question is it possible that there is a mind, a conscious being, a God, an intelligent designer behind it all, and the way he created the universe, stars, planets, life, complex organisms, all the way up to us in sentience, is these laws of nature that scientists are discovering. That's how he did it. He did it through these particular laws: gravity, natural selection, and so on. And therefore, you're kind of taking out of the equation this sort of personal God, you can still believe in that, but separately from that, this is how he did it. So in a way, back to the old natural theology arguments of the 18th and 19th century, studying nature is a way of getting at understanding God's mind, because those are the laws we're discovering. That's how God does it.
Yeah, I think that's a fantastic point, and one not too dissimilar to the point I tried to raise to Meyer, which is this notion of kind of lethargy or slothishness of the deity. So assume the deity existed. He instantiated the laws of the universe. He even programmed in that carbon could form in the heart of certain types of stars from a triple alpha nucleus collision that lasts for a trillionth of a second under these exact chemical stars, and that would create carbon and then phosphorus would come later, and then GCTA would, they'd all precipitate out and in different forms, and it would all part of this God's plan. Still, it would have to be that the deity instantiates that at very early times, because there's no censor, there's no interaction, there's no on a continual basis. I don't think people believe that God is in there separating RNA and matching up pairs of DNA strands, et cetera, et cetera. So it is kind of the clockwork. What's that? So therefore, the God that Stephen believes in, I said to him, the inescapable conclusion is a deist God. It's not a personal God. In other words, it is a God that established the laws that you and I would evolve. And so God created those. Let's just say I stipulate that. I believe there was an intelligent, let's say I do. He would have had to do so at an extremely early time, billions of years before Homo sapiens would exist. And then the form of Jesus Christ would come 2,000 years ago. So if that is true, then God established the laws of nature that by which we are to grasp his interactions with humanity extremely long ago. So how is that different than the deistic God, the unmoved mover, or the first cause God? To me, it doesn't display any difference functionally. But so then so I think it's a very different thing. And I asked him, can you get ought from is, but can you get Jesus or whatever, or God of Moses and Abraham? Can you get that from is? In other words, the fact that the universe obeys laws of physics, the laws of biology and biochemistry, and eventually sociology and political science and everything. Can you get those laws? Can you get a personal God from those laws? I don't personally see how you can, but that doesn't prevent me from looking. See, here's the thing I have trouble with agnosticism, even myself. I don't believe that there's such thing as like a super happy militant atheist. Like just because you express your opinion really forcefully doesn't make it any more so than my opinion as a happy Buddhist, or whatever, right? It's just like, okay, that's just your form of expression. You yelling at me, the God doesn't exist, doesn't help convince me any more than a quiet, reasoned argument would have us. So, I like to think about, where would God display his existence if he would? And then what would that consequence? So we all talk about that we'd settle for what Woody Allen called the divine sneeze. Like, that's all I want, a divine sneeze. And I hear that a lot from my atheist friends. They'll say, actually, I was reading a book recently by Avi Loeb, who and you had on the show, right? You had Avi on, right? Yeah. So he said, oh, well, if God really didn't want Abraham to sacrifice Isaac, he wrote this in the pages of that trash pile of a magazine called Scientific American. Now, I'm just mad that you're not writing for them anymore. But anyway, he wrote this in Scientific American. I love Avi, but he said, all God needed to do is give him like a modern day iPhone, and he could have recorded it. And I said, Avi, come on, you're a Jew, you're an Israeli, you're Jewish like me. Did you not forget the story of the golden calf? He's like, no, of course I know that. Every Israeli, no matter how secular they are, Michael, knows the Bible, the Old Testament, better than any Sunday school preacher of highest intensity that you'll ever meet, because they get it in their public schools. They learn the Torah. But anyway, I said 40 days. Imagine this, 40 days after witnessing 10 supernatural plagues devastate Egypt, the most powerful superpower country ever existed in human history at that point, and then split the sea, another miracle, and do all the 40 days after that, they melt down some gold and make an idol. And these are supposed to be Jews. I said, Avi, we're supposed to be kind of smart. Like 30% of Nobel Prize winners in physics at one point were Jewish people. We make up I'm not a Jewish egotist. I mean, all you have to do is get in front of one of my fellow tribal members at a certain event, and you'll realize that they're just human beings like everybody else. But I said, Avi, do you think human nature has changed? In other words, if tomorrow, Stephen Meyer's book gets a blurb from God and it says this book is is my favorite book of all time, do you think like a day later? Yeah, right. Do you think a day later? Well, that's like O.J. Simpson's book, right? If I did it. But do you think a day later anyone would still believe it, or a week later? No, we'd come up with different explanations. I remember hearing in the Soviet Union in the 1980s, it was very, very anti-religious, and there was, there were people and that would work for the, in the physics departments, et cetera, who would say things like, the splitting of the Red Sea was just caused by a huge windstorm, and there was a gravitational pull because there was an eclipse back then. And I actually had Richard Friedman, who's a dear friend of mine. He writes about the different. But is that any better? Is that any better or worse than a miracle? I mean, so to me, it's kind of
well,
it's
in a
kind of
way
hopeless.
that,
So what
that would be a miracle.
Yeah, go ahead.
I mean, that would be how God would do it. How would God actually perform the miracle of splitting the Red Sea? Well, he would generate up a super storm with strong winds, and he would have an earthquake or whatever. And this is what I'm getting at is this question of, well, how does God do it? How does the mind interact with the stuff? How does it reach into the universe from wherever God is and stir the particles in some way to cause the miracle, or laws of nature or whatever? I just had on the podcast two philosophers, James Davison Hunter and Paul Netoliski. They wrote this book called Science and the Good. It's a critique of myself, Sam Harris, Steve Pinker, and Jonathan Haidt, and others that are kind of doing evolutionary ethics. And the entire book is basically a critique saying this is why these guys have not explained the origins of morality, much less how to derive an ought from an is. Okay, so I reviewed the book and I liked the book, and then I thought I'll just have him on the podcast, so I did. We're going to release that in a couple of weeks, I think. In any case, turns out they're theist philosophers, both of them. I had no idea. So to their credit, they wrote this book without ever once mentioning God or anything like that, or even their positions. So we spent most of the time talking about why evolutionary psychologists and ethicists are wrong. So I said, okay, then how do you think it happened? Where do you think is the origins of morality? And in so many words, it was, God did it. It's like, yeah, I know, but how? I mean, in other words, it's kind of a God of the gaps argument. And even though modern intelligent designers disclaim that, they said, we're not filling in the God of the gaps. Well, you are. You're just saying in so many fancy words, God did it. Well, but how? And then if it turns out, they have some argument, well, he used the storm to cause the sea to split, or he caused the quantum foam fluctuation, and that's how he created the universe. How is that any different from what scientists are trying to do to figure out how it happened?
Right. And that's one of the problems I actually have with people like Neil deGrasse Tyson and Michio Kaku, again, guests on my show. And so I say it with respect. Sean Carroll made this argument to me in person a long time ago that, Isaac Newton knew that there were these gaps in the Principia, in the theory of universal gravitation, rather, and that the only way he could plug them, the instability, because gravitation is the only force that's only attractive. It has no repulsive gravity in the particle to particle sense, the way that electronic charges do, et cetera. Nuclear forces can have repulsive forces. And so he plugged that hole by postulating that God or angels kept the particles in place at certain times in their orbit when they're so-called gravitational resonances. And Stephen Meyer, to his credit, did the research. He was at Cambridge after all, and he looked through the Principia. There's not once does Newton make that argument. And so you have to be careful with the God of the gaps on the other side. I feel like, for the secular community to have more intellectual honesty than the theist community, they have to have higher intellectual standards. And to me, to let that slip, and Stephen's documented this particular that's a huge lacuna in their case, as far as I'm concerned, because I actually believed that for a very long time. And you can read it in Kaku's book. He talks about it. Also, Kaku talks about the famous questions of Thomas Aquinas, and those better than anybody. But one of those is like, anything designed had a designer. And Michio's just kind of glibly, he says one of those is a good question, where did the universe come from? But then he says, oh, well, like evolution explains the origin of life. And I'm like, actually, have you read Darwin's letter to Huxley? Where he says it's as much rubbish to think of the origin of life as it is the origin of matter. And it's like, no, the origin of species is what Darwin was talking about, not the origin of life. Those are hugely different things. And Michio just says, oh, no, evolution explains the life. No, there's not a single working experimentalist in the field of origin of life research, which is going on around the world, that has ever been able to replicate even the most simple versions of it. So there's a huge, I'd say, disadvantage to trying to take on the Meyers of the world. There's many, many obstacles, rather, there's one huge obstacle to accepting God, which is just like the implausibility, and the hiddenness of such an entity if he does exist. But the other, I feel like atheists have it really hard because we don't understand the origin of life. We're not any closer than we were 100 years ago. People talk about the Miller-Urey experiment. That was done in part here. I mean, Urey and Milner were both here in San Diego.
Well, Robert Hazen has a nice course at the Teaching Company. I think it's like 24 lectures on the history of the origins of life research. There's actually, a dozen different theories. Back to the consensus problem, there's no consensus. There's not an emptiness or a lack of theories about how it happened, including directed panspermia or just panspermia in general without the direction. But there's no consensus. So, okay, maybe it's a super hard problem. Maybe they're just not asking the question the right way or whatever, but again, we what's the alternative? Well, God just did it. Well, how? Did he use RNA to create DNA? Because if that's how it happened, then we should continue with that research. Or did he use on some other planet, he used some other self-replicating molecules that weren't either RNA or DNA? Okay, that would be interesting. But what exactly did the deity do or whatever? Anyway, so a more broad question, since you used the word agnostic to describe yourself, this word was coined by Thomas Henry Huxley in 1869, by which he meant not knowable in any kind of empirical or rational sense. There's no experiment you're going to run. There's no set of clever arguments like the Kalam cosmological argument or whatever that everybody's going to go, oh, yeah, that's right. It's just not knowable. So, I mean, today, most people use the word to mean like, well, I'm agnostic about climate change. Maybe some new data will come in and then I'll make up my mind and decide if I believe or if I'm still skeptical. No. So one position, I'm conflicted about this. I tend to think we're never going to know, right? It's just, we've all hit this epistemological wall. Maybe it's an ontological wall. Maybe we can never know. It may be an unknowable concept. Or maybe I'm wrong. Maybe the kind of universe we have is the kind of universe that would imply there's a God if you follow Stephen Meyer's arguments, or to follow Victor Stenger's arguments in his book, God, the Failed Hypothesis. He says, no, actually, God is a testable hypothesis, and he failed to test, and here's the 10 reasons why. And so I'm just curious what you think about that. Is this an unknowable concept? Is that what you mean by agnostic, or do you mean I'm waiting for more evidence to come in or better arguments?
So I kind of got this from Freeman Dyson, who called himself an agnostic, but again, he was functionally indistinguishable from Richard Dawkins. I used to tease him. I regret teasing him, because he's such a sweet man. But anyway, we had a great kind of friendship that I think about and miss him all the time. But one thing he said to me is, he said, Brian, there are two different things in science or in life. He said there are mysteries and there are puzzles. Like a puzzle, my kids can do a Rubik's Cube. I can never do a Rubik's Cube without like taking apart, and reassembling it. Actually, I could do it. I joke, if you gave me a Rubik's Cube that was solved on 5 sides, I could get that 6th side, no questions asked. But that was a puzzle, meaning it was something that somebody smarter than me, if not me, could do and solve. A mystery is something maybe no one can ever solve and is unsoluble and insoluble given what we have as human beings. But that wasn't a problem. That wasn't a reason for despair, according to him, and it isn't for me, because we all, there is a part of life, even if you're religious, that you have to make up meaning, whether that meaning that you make up for yourself is based on, what you want to have happen to you in the afterlife or what legacy you want to leave to your kids. What I find so delicious about life is in practice. So I get to practice not just physics, but experimental physics. I get to build telescopes. I get to go and search in cool and interesting places. I get to interact with smart people from around the world and think for a living and convert food into brain, into writing, into words that someone else maybe 20 years from now will encounter. So for me, that's the mystery aspect of it. There's no proof that any one of us is going to ever get the answer and solve it. For example, it's not for lack of trying. I don't feel very convinced by, kind of the militant atheism. And so I gravitate towards a practicing agnostic. The emphasis is on practice. So for me, I go to temple. For me, I study Aramaic, and I taught myself Hebrew at age 30. I was an altar boy in the Catholic Church. Both my parents were born Jewish. Biologically, I was Jewish from birth, just the same way that I would say we were Jewish in the same way that Panda Express is like authentic Chinese food. It was just like cultural. Like we'd go to synagogue. We used to joke, 2 days a year on Christmas and Easter. But then when my mom, remarried and she got married to an Irish Catholic man, Keating, I fell in love with the Catholic Church. And I became an altar boy, Michael, this Jewish boy at age 13 when I should have been having my bar mitzvah. I never had a bar mitzvah. Instead, I was confirmed, baptized, and I was an altar boy until I learned from Father Monsignor Robert Skelty in Chappaqua, New York. I learned that you had to be celibate. And at age 13, that wasn't something I was super interested in. I don't know why, but that didn't appeal
what was
to me
the appeal
at the time.
what was the appeal of Catholicism at that time to you?
I thought it was its authenticity, its seriousness, its lack of kind of frivolity. I didn't see people going there with sandals and flip flops, and people laughed. It's a very warm religion. It's very loving and open. There's an emphasis on food and drink. It's like they're forbidden to have a sexual relation, so they kind of malleable, in terms of drinking and smoking cigars or pipes. Anyway, it seemed very interesting to me, and it was part of an elite, and I loved that aspect of Catholicism until I learned about this guy Galileo and how he was mistreated by the Catholic Church, and even by the 1980s when I was an altar boy, he hadn't been pardoned. He's never been formally pardoned. The Vatican did admit that they were wrong. By the way, it wasn't like the Pope was some expert scientist. They have scientists to this day, Michael. The Vatican Observatory is one of the best telescopic observatories on Earth. And there were a lot of things I liked about the Catholic Church's science in that Lemaitre didn't want to claim evidence for the Big Bang based on his Big Bang model that he ushered in. But that's moving aside from the point. So then I became an atheist. I believed anything that did any harm to a brilliant intellectual like Galileo was not for me. And as I talk about in Losing the Nobel Prize, I thought, well, Christianity is kind of Judaism 2.0. And by modus tollens, if I can refute the conclusion, then the antecedent must be refuted. And therefore, I don't need to study Judaism. And there things stood, until September 11, 2001, when I realized I knew almost nothing about the religion of my birth. And for some reason, this religion played a big role in the evolution of our universe in its current state. So I decided then and there I wanted to learn more about Judaism. I wanted to have a Jewish family and to learn, and that required I learn Hebrew, which is really hard at age 30.
Well, now what's 9/11 got to do with that? Because of their hatred of Jews and anti-Semitism and anti-Israel?
It was more like, how is Israel? Why is this tiny little country that I previously had no affiliation for? Why was it in the center of all these events going on, the center of the Western world, and what role did it play in America's founding, for example, and what role did it play in the current political dynamic of that war, the Second Gulf War that then was becoming. And it just made me feel like an ignoramus because I knew nothing about Judaism. Like, it's one thing to not be Jewish, and look, I don't know much about Islam or being Mormonism, but I do know about a little more about Catholicism at that point than I did. I knew a lot of the arguments for atheism. I had read a lot of the earlier work, but for me, it comes down to practice. So as an agnostic who practices, not that I know that it's unknowable, but if you desist from the quest, like when you're out mountain biking or road biking, I bet sometimes you don't really feel like going out on your bike, Michael, but you do it anyway because it's part of who you are, and it's influenced your entire character. So for me, it's had a wonderful influence, Michael. Like once a week to have a day off where I don't send you an email. I'm not going to be on Twitter. I know you made fun of me because I took so long to get this article done. You're like, get off Twitter. I'm like, I'm off. It's 25 hours a week, but it is refreshing. It is restorative. And so I said, there's an accumulation of evidence that at least the activity of this life is beneficial to me. And then at worst, in kind of Pascal's wager, what's the worst that can happen? I lead this life true to this religion. Maybe I never come to the firm belief that my rabbi has in the existence of God. But if I desist from trying, I know I'll never believe it. Like Richard always says, there's no such thing as a Christian child. Like he says, he basically has called it like child abuse to say like your child, or Zuckerman has said that like no one's born into a religion, like no one's born believe. But I know something, from experience that actually it's extremely difficult to be born to atheist parents and to become religious. It's just that's just a truth. Like I think it's because of the way that atheism is sort of almost in opposition to an existing paradigm, that the practitioners, namely the parents, will really make it almost like a forbidden thing for their kids. Not like literally, but the kids will get this perception that this isn't something for me. And I didn't want my kids to go through that. And so I've left it open, and they're learning, and I'm learning, and it's just continuing that as a lifestyle. And who knows what will happen along the way.
Yeah, I think here you're touching on the, social and psychological benefits of religion that really have nothing to do with intelligent design theory or quantum physics or any of the stuff we're talking about, which, you and I love these conversations, but the average person going to church or synagogue or whatever religious service they go to, they're not going there to hear some arguments for the fine tuning or the first cause, the prime mover, the Kalam cosmological argument. They're going there for the camaraderie and the social aspects, the food, free parking, the kind of moral uplifting stories that much of the biblical stories convey. So, I mean, one of the things, points I always make about mythic truths versus empirical truths is that, for example, if you're arguing, well, the miracle of the parting of the Red Sea, the actual natural explanation for that is this windstorm or the earthquake or whatever. I think if that's the route you're taking, you're kind of missing the point of the story. The analogy I make is like, well, were there really 4 brothers Karamazov in Russia in 19th century? And it's like that, Dostoevsky just made this up, but it's not completely made up. There's a kind of a literary or mythic truth in the story about human nature, about human culture, human history, and the tensions that happen when a kind of a backwards nation like Russia becomes modern and goes through these states. That's it'd be like J.K. Rowling holding a press conference and saying, this whole Harry Potter thing, it's actually true. I didn't make it up. There really is this place, and the 9.5 at the train station, and there's this guy named Voldemort. No. I mean, this would be absurd. People would rightly think she'd lost her mind. But to even talk about that is to miss the point of the story, right? So I often think,
right.
Me and my fellow atheists, including things we've published in the magazine, we published back in the 90s an article that Jesus, this is before Dan Brown, it became popular, that Jesus was never really dead on the cross. He was kind of slipped into a coma, and they gave him this substance that put him in a 3-day coma. And so he's now in this cold tomb that kind of preserved the body for a couple of days. Then he wakes up. And then he and Mary whisk off to, well, the theory was India at the time. I think Dan Brown sent him off to France to have children and so on. But as interesting as those are, I think you've kind of missed the point of the resurrection story. It has nothing to do with, did he really raise from the dead after 3 days and so on. I mean, a lot of Christians absolutely think that has to be empirically true, or else why bother being a Christian? You can just be a Jew, say. Because Jews, they accept that there is going to be a Messiah. He just hasn't come yet, because the story of Jesus is not what the Old Testament predicts that, well, this is what Jews say, that would happen, and that's not who Jesus was. Okay, fine. But again, there's a deeper point to the story about, redemption, starting over, the oppression of the Jews by the Romans. And this is a common theme throughout history, is that oppressed peoples tend to have mythic stories about a savior coming, and like the Native American ghost dance that I like to tell. In 1890, the closing of the American West, the U.S. government is oppressing these Native Americans, putting them on reservations and so on. And all of a sudden, this thing erupts. The Dakota Sioux have this ghost dance in which they're all chanting for days on end about how the buffalo are going to return and the white man's going to leave, and they had these vests that they would wear that they believed would be impervious to a white man's bullets, and on and on. It's very much, this guy Wovoka, he was very much a Jesus-like Messiah figure, and in one of my books I have half a dozen examples of this throughout history, where oppressed people, so that's what, to me, the story has much deeper meaning To which someone like, my fellow atheist would say, well, it's just not true. So it's a bunch of bullshit. We don't have to even think about it. Well, that's too simple, kind of a interpretation of these things.
I think it is. I mean, one of my favorite things, Jefferson had a Bible where he removed all the miracles, and I'm working on my magnum opus will be a Bible with no violations of the laws of physics. And actually going through it, there aren't that many violations of the laws of physics. And in fact, there are very interesting kind of, either they're jokes, Michael, or like, kind of insider, kind of humor, where you have things like the sun is created on the fourth day. So it obviously can't be that they meant day. Now the question is, what did it really mean? And, and how do we interpret it? But I think they're, again, I've said this in talks I've given, looking at the Bible and expecting it to have anything to say about not just Noma or anything like that, but expecting to have anything to say about physics or cosmology or biology and heritability is like looking at, a transcript of the, 2008 housing crisis, kind of autopsy of forensic report, and then say, oh, this is really going to tell me how to, raise Labrador retriever. Like, it has nothing. Maybe the word Labrador appears in there once, but I make the point, and at one point I said, there's about 35 verses in Genesis 1:1 about, through chapter 2 or 3 about maybe the Big Bang or the origin of species, whatever. And then there's 35,000 total verses in the Old Testament, which is all I really know. And so that's 0.1%. So it's 1 out of 1,000. So imagine you pick up a book and it's 1,000 pages long, and it says on the cover, it says great, basketball heroes on it. And then like there's 999 pages of the 6, really outstanding Jewish basketball players that have been in NBA history. And then there's one about LeBron James and Michael Jordan and, and by the way, one of them was a convert, I think Stoudemire. Anyway, the point being, this is not a book about that. And nor is A Brief History of Time a book about how I want to raise my kids. So, and not that I raise my kids according to the Bible, but there are very interesting things about the Torah that, would be a great, part 3 someday to talk about. Not the science of the Torah. I really find those kinds of things, ridiculous, because it's clear it's not, again, the sun is created on the fourth day. It doesn't take an apologist to say it obviously doesn't mean what we think it means. But by the way, I have to tell that to my religiously inclined, Jewish friends. We'll say this is proof, that God can do a miracle, that he created it before the sun, and the sun is. That had a very specific purpose. It had to speak to readers 3,000 years ago or whenever it was compiled and written, and it had to speak to readers today. And I always joke, I kill for 1% of God's book sales. And that's serious because, this thing has been relevant a lot longer than A Brief History of Time. A Brief History of Time, I hope it's out of date. I hope my losing the Nobel Prize is not read in 100 years because we know so much more about at least the physics. But, I've often thought, it would be a bad thing if science doesn't get overturned. But how much more so is it good that things like the Torah and the Talmud, which is the second holiest work, they've endured for thousands of years. There's a reason for it. And it's not just mass delusions of crowds. There is wisdom, but that's not to say it comes up as easily as even string theory comes to certain people.
Brian, we've been going over an hour and a half. Let me just switch to the lightning round here and ask just a couple of quick questions back to your article for us at Skeptic. Let's see if we can keep these short. What is gravity?
So gravity is the weakest of all the forces. It's in some sense the most mysterious, not only because it refuses to be wedded to the other forces in some kind of theory of everything, should such a thing ever exist, but it hides what it does in inscrutable places. So gravity is responsible for the large scale features of the universe, but also the small scale structure of the Earth. The size of animals is related to the strength of gravity. It's the porous understood, the constant that governs gravitational interactions. Irrespective of it not being found a theory of everything, we understand the gravitational constant of Newton's law, capital G. That's the poorest known of all the so-called fundamental constants of nature. It's very hard to measure it on small scales. It's even harder to measure it at the earliest times. And it may be impossible, Michael, to measure it in the situations where it is most interesting and relevant, i.e., at the center of a black hole, what's called a singularity, or perhaps at the beginning of time, which is a moment preceded by no other moments, because those are firewalled off by the expansion of the universe in one case in the Big Bang singularity, and by the so-called event horizon in the context of the black hole singularity. So it may be that singularities don't actually exist, but we'll never know because they're both completely inscrutable. So gravity,
let me ask you this
keeps
question.
us all.
When I drop this object,
Yeah.
It's not being pulled to the Earth by a force. It's what? Pushed by space-time, I think is how Michio described it. And even that intuitively doesn't feel quite right.
I heard that description. It's an interesting description. So what happens is gravity warps the paths of trajectories such that if the object will fall with what we perceive as a curvature, as it will take the shortest amount of time, and it will behave as if it's being accelerated. But there's no actual reason that the gravitational force that pulls on the phone when you drop it should be mediated by the same term, this charge that we call mass. There's no reason that mass should be the same as to push an object. The fact that they are exact agreement to 12 decimal places is one of the greatest mysteries of all time, and is one of the ones that Galileo first perceived when he apocryphally maybe dropped the cannonball and a ball of wood off of the Leaning Tower of Pisa. And we're still learning things about gravity every day. It's the most mysterious of all the forces, and maybe we'll never be able to unify it. There's no law that says we will.
What is time, or space-time, if you prefer?
I only can say what time does. So time is intimately connected to change. In fact, that is maybe the most basic law of all of physics, is that change happens, and that change is what clocks can measure. So our bodies are clocks. We have psychological time, but I actually mean the physical degradation of our cells is a type of a clock. There are clocks, celestial events that occur. These are things that clocks can measure. And so time, and it's almost tautological. You can almost not separate the behavior of what we call time from the existence of clocks. And so it's no surprise that actually the first measurements of gravity by people like Galileo came about at a time when the first clocks were kind of coming together. And so for that reason, it's almost impossible to answer the question of time without referring to entropy, and entropy being the tendency of objects within a closed system to get more and more disordered from state description to state description. So we don't have a great description.
If the cellular disintegration due to entropy is happening at a certain rate as a clock, why does it slow down if I'm at a high speed, if I'm moving at a high speed, compared to somebody who's just stationary?
Yeah, so that occurs because of what is called time dilation, which is a distinction that you think of as puzzling because we don't have experience with things operating at the speed of light. Mm-hmm. So the notion of if you're sitting on a train and the train pulls away next door to your train, it feels like you're moving, even though it's really the other train moving. That's a consequence of what's called Galilean relativity, which governs the behavior of things in motion at low speeds. Galilean relativity is the extreme limit and the low speed limit of Einstein's special relativity. So the theory of special relativity incorporates two changes that take place. Lengths get smaller and time gets bigger. So you can close a barn door on an object that's nominally bigger than the separation between the barn door and its wall if this object is moving fast enough relative to the barn, which is stationary. But also things like muons, which have been in the news lately, they will live longer if they're in motion in the cosmos at high velocities, accelerated by a supernova explosion, perhaps, than they will on Earth at stationary in the laboratory. That's called time dilation. So, but the total interval, so in other words, the sum of time, the effects of time, that time gets lengthened and distances get contracted, they're conserved. In other words, the product of the time times the lengthening of time, the speed of light times the lengthening of time, and then the shortening of length, that you add those up, you get the same amount. And that's deeply related to the conservation of energy. So that phenomenon that you are witnessing is a byproduct of things in high velocity and the conservation of energy, are most closely held of all physical laws.
Okay, what is nothing? in this sense, let's just ask it in the deepest possible way. You have a box and there's nothing in it. So you take the universe, you take all the stars and planets and people and all the atoms and so on, but there's still ideas or logic or math or the laws of nature, whatever those are. So you'd have to take those out, and there can't even be any sentience asking the question, and there can't even be nothing, because nothing is a concept for it not to exist. At some point, I don't even know what I'm talking about.
Right. Well, I think about, so of course that's impossible to answer, but I will say something. You can get all the integers if you start with nothing. Now, I don't know if you've ever gone through this. It's called set theory. There's a wonderful book called Naive Set Theory. It was my late father's favorite book by, I think, Paul Halmosh, with an umlaut in there somewhere that your wife will appreciate. And the way you do it is kind of interesting, because a lot of cultures, think of God as one, and then, kind of everything else is emptiness. So it's really a foundation. The universe is kind of binary, and I'm not going to get woo-woo, I'm not like that. But the universe is kind of binary in that you can get one starting from zero. And the way you do it is this. Michael, how many sets of 0 bananas are there?
One? I don't know.
There's one set, right?
Yeah.
Okay. So, and then what does the set of 0 bananas and conceive of no apples or a universe with nothing in it? How many empty sets are there? There's only one set that contains no elements within.
Okay. All right.
And so therefore, starting with nothing, you get 1.
Okay. All
and then starting with 1 and 1, you can get 2 and 4 and 6, and you can get all the integers at least that way. All the rational numbers that way.
Interesting. Yeah. So could you get a universe from nothing? In here, you guys start talking about like quantum foam and the fluctuations and the colliding brains. And again, I get lost pretty quick.
So those are the mysteries, right? So they confuse us because they present as puzzles, but they're probably mysteries.
Yeah. Well, Brian, this is an unbelievably fascinating conversation, because we've dealt with pretty much all the big topics. Did we leave anything out? I think
I know
we went way beyond your cover story, which I really appreciate. All right, there's your next book. You have to put all this together and respond to all the intelligent designers and everybody else on the spectrum, as it were.
I know. I'm like an equal opportunity offender.
What is your next big project? What are you working on? What are you working on?
I'm working on the first audiobook translation, recording of Galileo's dialogue with Carlo Rovelli. And then I'm working on another book called Think Like a Nobel Prize Winner. I've interviewed 9 Nobel Prize winners and counting on my podcast, Into the Impossible, on YouTube, Dr. Brian Keating. And I'm working on that book. And then I'm also maybe thinking of writing a book about the things we leave behind and what are known as ethical wills, what we want to be remembered by us, not monetarily, et cetera, but in terms of what impact we made on other humans through our wisdom that we've acquired. And those are kind of keeping me busy, along with teaching.
Like the environment?
Yeah, the environment, but more like what wisdom. And I actually asked this of Ann Druyan, widow of Carl Sagan, among many other people on my podcast. I always ask them. I didn't ask you, because I started asking these questions after you came on my pod. You gave me my start in podcasting exactly a year ago. And so it was before I developed these patented questions that I now close each and every episode with. And so when you're on my show next, I'm going to ask you these questions. But one of them is, what would you put in your ethical will? And another one is, how did you go into the impossible, which was Arthur C. Clarke's famous line. The only way of knowing what's possible is to go beyond the limits into the impossible. So, yeah, I'm working on a whole bunch of different projects, but really the Simons Observatory, building this telescope in Chile with 300 of my closest and best and brightest scientists in the world, that's going to keep me busy for the next few years. We hope to deliver.
Your scientific project is that, the Chile. I didn't know you were working on that. Oh, interesting.
That's my main project.
What is the hope that it will detect or discover or see?
Yeah, so we don't talk about what we want to discover, else we get diluted by Nobel Prizes and such. But what we are designed to look for are the imprints of early gravitational waves in the infant universe, if they exist. As I talk about in the Skeptic article, those would be perhaps the only harbinger, the only imprimatur of inflation, which comes along concomitantly with the multiverse. And then, but also for clusters of galaxies, for the imprint. Michael, we don't know where magnetism comes to the universe. We don't know how it originated. So we talk about these highfalutin laws of gravity and string theory. We don't know where the earliest magnetic field in the universe came from. We don't know what caused it. And that's one of the things we're designed to detect. And then the last thing is that I'm hoping to look for, not to discover necessarily, but it would be more startling to me, Michael, than discovering inflationary gravitational waves. And that's called Lorentz violation. So Lorentz invariance is the symmetry, is the founding principle of physics. It basically means that I don't care if I do this experiment dropping my phone here in San Diego or in Santa Barbara. It doesn't make a bit of difference. It's independence of location. It's independence of time. You could do it in 1600 or you could do it today. It will behave the same way. What if it doesn't? We actually can't test things over very big distances here on Earth at very long times on Earth, but we can with the cosmos. And so that's what I'm looking for. We're looking for departures from the basic underpinnings of all of modern physics, namely Lorentz invariance. And if we find that, to me, that would be more interesting than discovering the origin of the universe via these gravitational waves.
Yeah, that's fascinating. That's Lyell's principle of uniformitarianism. The past is the key to the present. Maybe it's not. Maybe the speed of light was different in the past, or gravity was different, or whatever.
Right. That reminds me of the last thing I'll say about that Hawking book. There's a scene in there where Hawking had a party in Cambridge I think it was in the maybe the early 2000s or maybe not even that long ago. And then the next day he advertised the party and he said, come to Cambridge at this time. And he said, and at the party, he said, welcome time travelers.
Right.
And so, yeah, all these things are very, very interesting. Can we discover that the laws that we already know that certain properties of physics depend on whether you're looking at them in a mirror or not, which is very bizarre. In other words, if I look at this Leatherman, multi-tool falling down, it doesn't matter. You're actually seeing the mirror image of it. You can't tell that that's happening. But there's certain phenomena called in the weak interaction that violate this symmetry property called charge parity. I wonder, and my colleagues and I wonder, if the universe has kind of a handedness to it. If it has a preferred direction in space and time, that actually we assume it doesn't, only because we only have such limited distances here on Earth and limited timescales in the human life. But through looking as far back in the universe as we can with these powerful telescopes, we hope to reveal that symmetries have to be broken. That's where interesting things happen. I don't know, do you ever see this thing, Michael, where they show a picture of Brad Pitt, who besides, you and me was considered the handsomest man on Earth by People magazine. Skeptic magazine had a different handsome man. But then they take his picture and they just split him down the middle and they just reflect once, and he's grotesque. He's horrible. He's disgusting. Even I'm better looking than him. And so symmetries, when they're so that means that broken symmetries are more attractive and appealing. So we're looking for those broken symmetries. So far, we haven't seen it. It means that nature is startlingly resilient and impervious to all of our testing, but that just makes it more of a mystery to hopefully turn into a puzzle.
Well, it would be interesting to come back 1,000 years from now, or be chronically frozen and woken up and then go, oh, that's the explanation for that. That was so obvious. Why didn't we see it in the 21st century? Well, all right, Brian, thank you so much for coming on. I really appreciate it. Great conversation.
Thank you, Michael.